We are very pleased to be speaking with Professor Stephen Epstein of the History Department at the University of Kansas, distinguished professor of medieval history, as it happens. And because he is a medieval historian, I've asked him to talk with us a little bit about how our ancestors, our pre-Galilean time frame ancestors, would have responded to an event like a total solar eclipse.
Okay, well, the first thing that comes to mind, of course, is that they knew about the existence of solar eclipses, but they could not predict them at all. They thought they knew that the Greeks could, but they'd forgotten how to do it. A few people knew how to calculate and predict a lunar eclipse, but I gather they're way more frequent and not as important. So when a solar eclipse actually happened, you got up in the morning and you didn't know what was going to happen. And then it happened. And it frightened them. No matter what they knew, it frightened them. Okay. And that's how it first came to my attention in the place I study, which is Genoa in Italy. And I'm going to check my notes here because this is where our areas of expertise overlap. On the 3rd of June, 1239, at noon, over this city, they had like what we're going to have, a 99% total eclipse pass over their city. And people didn't forget it. I mean, I work on a guy who 60 years later, this is one of his childhood experiences. I can almost estimate how old he is by the fact because we don't know when he was born, but everybody that saw this apparently remembered it until the day they died.
Wow. So that answers a question that I'm getting asked a lot. What will it be like? It's not totality, which I can read about and describe as admittedly a very unique and special experience, but all I've been able to say is it's going to be really dark. And I guess that's terrifying enough if you're not expecting it.
And you don't know. See, I also studied from the point of view, they considered it a catastrophe. It's like a natural disaster. It's always in that category. So they see comets. They haven't named Halley's Comet yet, of course, and they don't know it's coming back. But when it shows up, it's like an amazing thing because it lasts for weeks. And an earthquake, they don't want it to last too long.
Right.
And this, I gather, what was it, maybe 5 or 10 minutes before it started getting light again. See, it's the part of where it's getting darker and darker that frightens them, terrifies them.
You don't know it's going to end.
And some of them apparently believed that it was the end of the world because their religious views prepared them for an event like this. You know, one day we're going to wake up and that was going to be the end. And the disappearance of the sun, for ordinary people who have no knowledge of anything in my period, maybe 20 people in the city understood what a solar eclipse was. And they didn't have enough time to tell people to chill. They couldn't text it, you know. All they could do is run around town yelling at people, don't panic, don't.
It'll be over.
Yeah.
So they had lost the knowledge of the Saros cycle, which was known in the ancient world. But was that not at a level of knowledge that had
Well, the thing is, I mean, we're exactly trying to intersect our fields here. They believe that the Earth is stable and at the center of the solar system and doesn't move. And the only reason they understand anything is because they know the moon revolves around us and is closest. But the sun also revolves around us in their model, and that makes it, even by the old Ptolemy system, very chancy to predict a solar eclipse. And whether even the Greeks could actually do it or not, I'm not so sure. There's a scholarly consensus on that, at least of what I've been reading lately. But lunar eclipses, they're fine.
So, was this something that happened during the middle of the day?
It was at noon.
At noon.
And in fact, because there are websites that I look at from time to time about earthquakes, or scientists keep this, and this one because they can project back. They know exactly. I've looked at the path of it, and it's a rather narrow total path across Europe, and it passed over them 1 hour after Greenwich Mean Time, which is pretty much noon in this place. It was high noon on a clear sunny day in the summer, and
everybody would be out and about.
Yep.
I've also heard of eclipses associated with big events. I think the death of Muhammad's son, where the sun went down while it was still in eclipse, and I can't imagine how terrifying that must have been.
Well, they have their stories. I mean, they believe the world got dark when Jesus died, but it was dark for too long to be an eclipse. They know that.
Several hours duration, right?
Yeah.
That's much.
It's not an eclipse.
No.
And they also kept their eyes open. And the remarkable thing from my perspective is that nothing happened in that year. They were in the middle of a war. The war went on. Nobody important died. They would have expected the eclipse maybe to be a sign from God that something was going to happen. So they kept their eyes open, and nothing happened.
Literally nothing.
No earthquakes. I mean, that was the thing. It would be the connection. There'll be a bad storm. There'll be an earthquake. That's the main problem in Italy. That's what they expect. There are no volcanoes anywhere near Genoa, so they don't have to worry about that. Storms, also a possibility. No disease, which it might have also predicted in the past. But yes, nothing happened.
Nothing happened.
And we're going to hope that that's true here next month, right?
Do you see any resonance in what you and I have both heard from contemporaries of being taught in the past that it was dangerous to go outside during an eclipse, that it was important to avoid looking at any reflection?
They knew nothing about that, and I'm sure, alas, they all looked, but there's nothing in the source. It's interesting. There's nothing in the source that suggests there was, if there had been widespread eye ailments in the city, they would have noted it and considered the eclipse somehow connected to it. They don't.
Pretty quickly afterwards,
Yeah.
I would think.
So, no. I mean, but they don't even have eyeglasses yet, so I don't know how that would have affected one thing or the other about their sight. But no, there's no sign that their fear, and in fact, what's interesting to me and why I was hoping you would get more participation from other people was that what is in the history is a poem. Some guy wrote a 10-line poem about the eclipse, which is very rare that anything like that. It's like some artist responded to it. And the poem is just about fear. It's about how terrified we were.
I would love to see that.
Well, it's in Latin, so it's
Okay,
you can
need
see
a
it.
translation.
Well, you can try Google, or I'll take a hack at it because
I'll try.
it's not difficult Latin, but it's astonishing. And when I first read about this, when I was a graduate student, I just wrote in my notes, "There's a poem," and with a big question mark. And when you invited me to do this, I was looking back at my notes, and I realized I better look at that poem. And I could, now it's online, the whole thing that I sat in the library copying by hand.
We're speaking with Professor Bruce Lieberman of the Ecology and Evolutionary Biology Department at KU, and also the Biodiversity Institute, which is associated with the Museum of Natural History at KU. And we're here to ask the question, what can fossils tell us about the relationship between the Earth and the Moon?
This is a really great question, Barbara, and initially I might have thought that the answer would be absolutely nothing. But I was pleasantly surprised to find out about the potential value of fossils to our understanding of the relationship between our planet and the Moon when I was in graduate school, and it's something that's always intrigued me so much that I make sure that I talk about it in all of at least once a semester in the class that I provide for non-majors here at KU.
And I should say we're standing in a place that I have never been at KU. This is the Collections Department of the Paleontology arm of the Biodiversity Institute, is that correct?
Yes, so we're in the invertebrate paleontology collections right now. Most, but not all of our collections are housed in this building, And actually, the collections of several other divisions are housed here as well: vertebrate paleontology, entomology, etc. In a way, it kind of depends on which collection you work with, but some have a bigger presence out here, and we have a very active presence out here. Our collections manager, Dr. Julian Kimmig, is based here, and also several of the students work out here as well, partly depending on their project. But so in a way, it's a nice open space. There's lots of room for fossils, so it provides a lot of we have a lot of fossils, literally tens and tens of tons of fossils. So this is a place where we have the necessary space to be able to store them, make sure that they're well cared for.
It's kind of a fossil library.
Exactly. It really is very much like a library.
And invertebrate fossils. So we do have pretty firm fossils of these originally squishy little things.
Yeah, so most of the fossils that we do have are things, it's not 100% true, but the vast majority of the invertebrate fossils that we find in the fossil record are creatures with shells. Let's say an external shell, if you're talking about something like a clam or snail. Many arthropods also have an external skeleton. One of the things that we'll be looking at in just a bit are fossils of corals, and really they're primarily just the thing that the soft squishy organism excretes, and it's sort of those soft tissues are not preserved at all, or only very rarely in the fossil record. And most of the fossils that we have in this building, and in general as paleontologists, are those hard external skeletons, or in the case of vertebrates it would be the hard internal skeletons, or bones. That's usually what's preserved in the fossil record.
So I think we see with the way we're going to connect up the story with the Earth and the Moon, because we're talking about fossils that lived in, creatures that lived in shallow water where tides were a big feature of life and the flow of nutrients. So before we go back to the fossils, can you tell us a little bit about what we should be looking for?
So one of the things that we'll be looking at, or the fossils that we'll be looking at, are fossils of corals that lived about 400 million years ago. These aren't the direct relatives of modern corals, like the types of corals that form the Great Barrier Reef in Australia and also that you can find in the Caribbean, but they're pretty closely related to these corals. And one of the things we know from modern corals that also lived in this shallow ocean environment is that you can track their daily bands of growth. That is, they put down a tiny layer, basically of cement, every day, and these are further bundled into packages that are yearly and seasonal as well. So if we look at modern corals, we can see that modern corals consist of a big annual band with 365 smaller bands contained within them. And many corals are many, many years old, so we can find many, many of these daily and also annual bands. We're going to look at these fossils that are about 400 million years old, and we're going to find that there's a difference in the number of daily bands that we find in any year relative to the corals today. And we'll talk a bit about what that means.
Let's go look.
So what we're looking at now are fossil corals. They're informally referred to as horn corals. You can see the reason why, because they are shaped like a horn. You can actually, these fossils, the ones that we'll be looking at here, are from New York State and Michigan. However, we can find relatively similar ones in this part of Kansas. For example, if you're driving down K10 or I-435 and you see those yellow rocks that are by the side of the road, you can find fossils like this. They're a bit younger, but very similar in overall appearance. These types of corals are the ones that I said, they're somewhat closely related to modern corals, but the group that they belong to is extinct. But in many ways, they're analogous to modern corals, and this kind of just gives you a feeling for what one of these horn corals looks like in side view. So the animal kind of would have been sitting in the muck here and growing out, so this would have been the baby coral, and then really preserves much of its life. You can see it from the side here, and can kind of get the sense of these big bands here.
And is this an annual?
Yes, those would have been the annual bands. Just to give you a feel too, here's the top of the organism. And in fact, this one is branching. There's like a little baby coral that's coming out of the big one. So you can look at these annual bands, and then it's possible sort of to see even from a distance that there are sort of these tiny small bands. So if we take a coral very similar to that one, and then cut through it using a rock saw, you can see these bands even more clearly, and you can see how the skeleton is built up. So basically the actual organism, this is just sort of the dead skeleton left behind. The actual organism would have been right at the top, so this is when this coral died. The soft stuff would have been here. But as it grows up, it deposits a little layer of this substance, which is very similar to cement. It's basically limestone. And so if you look with a microscope, you can see not only these annual bands, but the smaller daily bands within. And looking at these corals, we find that the number of daily bands in a year was in fact about 400, in contrast to today's 365. So when the paleontologist who first discovered this back in the 1960s was like, hey, what happened to the day? The days, why are there only 365 days today? But the paleontologist spoke with some astronomers and physicists, and they came to the conclusion, in fact, that it wasn't like the Earth moved its position relative to the sun. A year was still the same length of time, but what had happened is through time, the moon, which will be the primary, one of the two culprits in the upcoming solar eclipse, had slowly but surely, through its gravitation, diminish the speed of the rotation of the planet. So a day 400 million years ago used to be about 22 hours. Today it's 24.
It's a 10% difference.
It has changed. And
striking.
And as you were saying earlier, sort of today the expression that we can see of this gravitational effect of the moon are the tides, so that it's moving the ocean, but slowly and surely the moon is also slowing the spin of the planet. And in a few 100 million years more, there will be even more hours in the day. This is really a great relief to us teachers. The amount of extra material that we'd be able to cover in a semester is dramatically enhanced.
But sadly fewer eclipses, probably, as the system progresses.
So it would change that too, as well. So it would change the dynamic of the eclipses as well. And so this is always one of those examples that I thought was fascinating to me as a paleontologist. You wouldn't think that a little coral like this that lived 400 million years ago might provide some information about the interactions between our planet, the moon, and also ultimately the sun. So it's just sort of records this record of what a day was like 400 million years ago. We don't have a great idea about necessarily, but at least we have a good idea of what its length was like. And the days used to be shorter back then.
I have no idea whether that is consistent with the rate of change of the Earth's spin right now, but it's very gradual, but it's moving to slower and slower spins, longer and longer days. The moon is moving farther away, and eventually, many eons in the future, will orbit each other face to face. But
really?
At a much, much greater distance.
Oh, that's fascinating.
So no more eclipses and a really long day and a month and everything else.
So it's not a bad time to be around.
Right, we're in the sweet spot.
Yeah.
Excellent. Well, thank you so much for sharing the fossils and this pretty neat place and that great story.
You're very welcome. Thank you for coming by. It's always great to talk to you.
We are meeting with Professor Stephen Hawley in the Department of Physics and Astronomy, and want to ask him about the solar eclipse coming up and plans to view it. And for most of us, for people who are really interested in being in the path of totality, the game is to find the best location with giving consideration to the time, the duration of the totality, and the probability of clear skies. I gather that early in your NASA career, you and your colleagues took a slightly different approach to planning how you were going to watch a total solar eclipse.
Yeah, that's right. One thing I would say is that despite many of the reports I've heard on television about this being the first total solar eclipse in the U.S. in 99 years, that's not quite right. There was a solar eclipse in 1979. It didn't cover a lot of the U.S. It was North Dakota, Montana, some of the Pacific Northwest. But the significance for me was that we had just been announced about 6 months earlier as the first class of shuttle astronauts. And so 3 of us who were science types had decided that what if we organized an expedition to the 1979 total solar eclipse using the NASA jets, and could we justify that as training for what we would do later on space shuttle missions? And we thought about it and put together case that said, well, you know, you've got to do some flight planning, you've got to look at the details of the operations, you've got to take data while you're in flight, you've got to work out a bunch of team crew coordination things. And so we, in fact, put together a proposal that said we would take 2 or 3 NASA jets and fly to North Dakota, and we would then chase the eclipse and take photographs from 43,000 feet. And we presented that proposal to our management, and at least to my surprise, I won't speak for my friends, but to my surprise, they bought it. And so we, in fact, did that. We took 3 airplanes and flew to North Dakota and staged out of North Dakota and flew the eclipse track at 43,000 feet, about 550 miles an hour, and got some documentation. And in fact, when we got back, it turned out that I think you could justify it as actually very good training for the things we would do later.
So the training was the big sell, and I would have thought it would be a hard sell as well, but apparently you were successful. Were there science goals as part of your proposal, and did you achieve any science goals?
We did get pictures of the eclipse, but I can't defend an argument that said we were really in this to produce science. It was, I mean, I guess in some sense you could say it was a demonstration of what would be possible from a jet airplane traveling at 43,000 feet with a handheld Hasselblad. But we did get pictures, but I don't know scientifically that they were particularly useful.
So the advantage of doing this from a jet or from space is that in principle you might be able to follow the shadow and get a longer duration of totality.
Exactly, yeah.
So
and I don't remember exactly, you know, all these many years later how long it was, but I seem to remember it was between 5 and 6 minutes we were able to achieve by flying the appropriate ground track and at those velocities. Plus at 43,000 feet, that time of year you're going to be above the clouds. You don't really have to worry much about being clouded out. As I recall from pictures I've recently seen of our expedition, it was in fact cloudy on the ground, so we may have been the only people in that part of the country that actually saw it.
And do you have any of those pictures? Is there any of this documentation still around?
There is. It was interesting. I had received a request several weeks ago from somebody that wanted to know if there was official NASA photography. And what I recall is that because this was officially a training exercise, and this was common in other training exercises as well, to learn to use the photographic equipment, you would check out the cameras, which we did. They were the same ones that we would use on real shuttle missions. But the photographs you took were critiqued by the trainers, but then they were not official NASA photographs. So I probably at home in some box someplace have negatives from the photographs we took. I do have some electronic images, one that I saved and a couple of others that I got from a friend of mine that was also part of the expedition that he sent me. So, but there's nothing official.
Well, of course, NASA plays a huge role in science education and promotion of science policy in the United States, and they are the biggest players in providing education information about the eclipse that I know of. And are they planning to do anything remotely like this on August 21st?
Well, from what I know of NASA's plans, they will, of course, broadcast the eclipse on NASA TV. I understand also there'll be an airborne observation of some kind using one of the NASA planes. It won't be one of the jets like we used. It'll be one of their larger jets. I don't know exactly what they're planning. And I know they're planning also to do something from the International Space Station using their crew there, who will probably be focused, I would guess, on photographing what it looks like from space if you look down on the Earth and see the shadow as it moves along. There's a fairly well-known picture, I think taken in the 90s from Mir, showing the shadow on the Earth's surface during a total eclipse. That's certainly a unique perspective.
Yeah, well, it sounds great. And where are you spending the eclipse, if I may ask?
I will be in Wyoming. I agreed to participate in an event that organized by one of my graduate school buddies who now spends a lot of his time organizing science-related events that people can choose to sign up for and go and experience different things. And so he's organized one in Wyoming at a pretty good site. Hopefully the weather will cooperate, but a good site in terms of duration. And so there'll be just interested people that he is hosting, and I've agreed to be part of that. So hopefully if the weather cooperates, we'll be in a good place.
The Greeks and Romans were keenly interested in the sky. Like many ancient societies, they paid attention to the positions of the sun, the moon, and the stars to help direct them from place to place and to guide them in determining when to plow, when to plant, and when to harvest. It's no surprise, then, that the supreme god in their pantheon, called Zeus by the Greeks and Jupiter by the Romans, is a sky god whose weapon is lightning, which you see here in his right hand as he is poised to strike. But Zeus's realm was the sky close to home. Farther out in the sky were other gods. The sun was a god unto himself, Helios the Titan, an ancient god who pulled the fiery ball across the sky with his chariot. Helios dwelled in the far east, in a golden palace in the ocean. Each day at dawn, he drove his chariot across the sky until he reached the westernmost part of the world, called the Hesperides, where he sank into the ocean and flowed back to the east to rise anew the next day. According to myth, at one time, Helios's illegitimate son Phaethon demanded, as proof of his relationship to the god, that Helios let him drive the chariot. It was a disaster. The poet Ovid tells the story of how the father warned his son not to undertake such a dangerous scheme, and if he did, to take it easy on the ride. But impetuous Phaethon let the horses run amok. The chariot careened too high toward the heavens, and the constellations fled in fear. Then it plunged too low to earth. Here's how Ovid describes the plunge in his Metamorphoses, Book 2. Phaethon sees the whole world on fire. He cannot bear the terrible heat. The air he sucks in feels like it comes from the depths of a furnace, and the chariot glows white hot. The ashes and sparks are unendurable. He is enveloped in a dense pall of smoke, and in that pitchy blackness he doesn't know where he is or where he is going, swept along by the will of the winged horses. They think it was then that the Ethiopians, as the heat drew the blood up close to the skin, became dark-complexioned. Robbed of their moisture, Libya's hills then were bleached into desert. The translation I just read was by Professor Stan Lombardo, a KU Classics professor and avid stargazer himself. After Phaethon's disaster, the earth goddess Ceres begged the help of sovereign Zeus, who blasted the boy and the chariot out of the sky. The moon was also a titan in ancient mythology. She was a sister of Helios, in fact. Her Greek name was Selene, and her Roman name was Luna. This goddess is seen driving her own chariot of winged horses, and she has either a full or crescent moon atop her head, as you see here. This image is the inside of a wide drinking cup. Imagine the delight as the partygoer tilts the cup to drink, and the brightly painted moon becomes visible as the wine sloshes around. The moon also has stories to accompany her in mythology. The most famous of these is her love affair with Endymion, a mortal man. She asked Zeus to grant him eternal life and/or eternal youth. Zeus put him into an endless sleep, and every night Selene visited her sleeping paramour. Some versions of this myth suggest Endymion was a shepherd, but others call him an astronomer, which would probably make their love more mutual. The story of Selene and Endymion was popular in ancient art. Here it is in a round mosaic from Roman Spain. Endymion was really popular on ancient sarcophagi or caskets, likely because of the way he's not dead, but forever asleep. So the Greeks and Romans had fantastic stories about the sun and the moon. One commonplace was that they were never in the same place together. The sun flew his daily round, and then the moon did hers every night. But myths were never meant to convey literal truth. They were stories meant to explore what it meant to rule the day or night, how humans aren't strong enough to govern the universe, and how even the primordial gods must follow the rule of Zeus, ruler of men and gods. Scientist philosophers approached the heavenly bodies in different ways. I call them scientist philosophers because the two were closely intertwined throughout much of the Greco-Roman period. Both disciplines involve a search for the underlying causes of things, a search for unchangeable truths, and the essence of nature. They observed and compared and thought and were unafraid to learn from other cultures, such as the Babylonians and the Egyptians, who, for 1,000 years, had already been witnessing the sky. A man named Thales is one of the earliest of these thinkers. He lived around 600 BCE, and he lived in the western coast of Turkey. Thales calculated the length of the year and determined the dates of the equinoxes and solstices. He calculated the position of several constellations and the diameter of the sun and the moon vis-à-vis their orbits. He also predicted the solar eclipse of 585 BCE. The Greek historian Herodotus tells the story. Herodotus tells us that the Lydians and Medes had been warring for 5 years inconclusively. The fight was in progress when the sky suddenly went dark. Thales, says Herodotus, had predicted such an event and the year in which it would happen. It happened on May 28th of 585 BCE. Here's a fun coincidence. In the mid-1990s, the British archaeologist Jeff Summers was excavating at Kirkenes Dağ in Turkey, and he sought to prove that this was the place where that battle took place. He wrote to NASA seeking help, and NASA confirmed that there was indeed a solar eclipse in that spot in 585 BCE. Our own KU colleague Phil Stinson, an archaeologist in the KU Classics department, was there at the ongoing dig in August of 1999 when there was another total solar eclipse. He had this to say about that experience. We watched in amazement as the darkness swept in from the west over the largely treeless and barren landscape. We have further and various responses to eclipses by the Greeks and Romans, who believed that the darkened sky was an omen to be purified by rituals restoring the natural order. Or it was the result of evil magic, since witches were said to be able to pull down the moon with spells and potions. Or it was a portent of horrible things to come. In 331 BCE, Alexander the Great, whom you see here on a Roman mosaic, crossed the Tigris River to attack the Achaemenid Empire of Persia. Along the way, a lunar eclipse occurred, terrifying Alexander's troops. Quintus Curtius Rufus, a Roman historian 400 years later, who wrote a history of Alexander, says that Alexander manipulated the troops' fear by hiring Egyptian fortune tellers to interpret the eclipse as an omen that was favorable to them. Curtius the historian does not suffer these fools lightly, neither the mercenary soothsayers nor the gullible troops. But Alexander won the battle. An eclipse affected another major battle in a more flattering story that Cicero, Livy, and Valerius Maximus tell. It was the Battle of Pydna of 168 BCE between Rome and Macedon, a battle that was the death knell of Greek dominion in the Mediterranean. Just a few years later, Greece became a subject state of Rome. On the eve of this battle, there was a lunar eclipse. An astronomer, who happened to be a Roman military tribune, knew the eclipse was coming, and with the permission of his commanding officers, offered astronomy lessons to the soldiers in advance so that they would know what to expect. According to Livy, the astronomer tribune said to the troops, "No one should think this eclipse is some sort of portent, for it happens in the natural order of things, and in set times, and can be known and announced beforehand." The level-headed Romans took heart and won the victory. This coin, minted just 2 decades later, commemorates the help of the moon. On the other side of this coin is the figure of Rome herself. Whether science or superstition, whether myth, magic, or math, the sun and the moon exerted a powerful influence over the ancient imagination. We'll leave off with the words of Archilochus, a Greek lyric poet from around 650 BCE, who describes pretty well what we will see here in Kansas on August 21st, 2017. "Nothing is to be expected or sworn impossible or marveled at, now that Zeus, the father of the Olympians, has made night out of the noonday, hiding away the light of the shining sun, and clammy fear came over the people. From now on, men can believe and expect anything. Let none of you any longer marvel at what you see, not even if wild animals take on a briny pasturage in exchange with the dolphin, and the crashing waves of the sea become dearer to them than the land, the wooded mountain dearer to dolphins." Thank you for tuning in, and enjoy the day.